Thank you everyone for being here. Yeah. So I'll start this session as mentioned with a talk. It's going to be a talk about Cowrie, what it is. We're going to talk a little bit about the history because it's about 10 years old now. It's been through quite a bit of development, new features and things that happen. So I'll tell about that. And then at some point, if there's not too many questions, we will convert this into a workshop. And that means that I'll give everybody opportunity to install this either on their laptop, or I have a few cloud virtual machines available as well if you don't have a machine to run this on. And we'll turn this into interactive. Yeah, if you only want to join for the first part, that's fine. Feel free to leave. Yeah, if you want to do the hands-on part, then do stick around and you get a chance to try things yourself. So my name is Michel Oosterhof. Thank you for the introduction already, but maybe tell a little bit more about myself. Yeah, I've been in IT security now for I think almost 20 years with different organizations. I started out in IBM, then worked at RSA, at Splunk, at HashiCorp, Anomali for a bit, and now I work at Google as a global security architect. This talk is about something I do in my spare time. It's not related to my job, but it has helped me throughout my career in various places, and maybe I'll mention a little bit about that on the way as well. Just how having a project like this can actually be useful for your career as well. So 10 years of Cowrie, and let's get started with what it is. Maybe I can see some hands. Who has ever heard of Cowrie or has worked with it? Okay, one. So that's good. So we got a whole brand new audience. So there's a lot of things to learn then. So what is it? You've already heard it's an SSH and Telnet honeypot. And start with the basics. SSH and Telnet, if you're not aware, are two ways to connect to a remote computer. Telnet is the, let's say, old-fashioned way that wasn't encrypted and wasn't really secured. And SSH is the modern version of this with a lot of encryption and better security around this. SSH stands for Secure Shell. And a honeypot is a system that is created to attract attackers. So it means you are setting up a type of system. In this case, it could be just a login prompt on a web server, or it could be an OT, IoT server, or it could be, in this case, a Cowrie system emulating an SSH server. And it's basically not there to do anything useful except to monitor people trying to log into it and to monitor whatever they're trying to do. And you could even say that one of the purposes is to keep the attackers busy trying to work around what is actually a fake system. So you would typically deploy these on the internet to learn about what people are doing in the terms of scanning. So you'll just put this open on the internet and see who's trying to log in. And if you go to the workshop, you should see some logins on your machine fairly quickly because the internet is being scanned continuously all the time. So you put this up and within a few minutes, you will see people try to log in. You can put this inside your organization. Yeah, and normally you shouldn't get a lot of data out of it because it'll just be sitting there. But if somebody does try to log into that, that's an interesting event and something you may want to send to your security team because they shouldn't be doing that. So that is what a honeypot is. There are many different honeypot systems. Some of them emulate one server, some of them emulate an entire network. Often they do it by particular protocol. This one is, again, SSH and Telnet, but you've got web server ones, you've got things like Modbus or other OT protocols. Any protocol you have, you could use as a honeypot. And actually, if you finish the lab at the end, we will be working with an SMTP honeypot as well to try to collect some spam. That will be the final exercise in the lab. Now, this is what we call a medium interaction honeypot. I think medium interaction is a term I invented. People always used to talk about low interaction honeypot and high interaction honeypots. Low means that maybe I will get a login screen and a prompt, and then when I try to log in, maybe the system will just disconnect me, but record that I tried to log in. High interaction will be a full system that you try to run and monitor. So I can put a full Linux server as well as a honeypot and then monitor what people are doing. But the risk is once the attacker gets in there, they can then use that as a jump host to go somewhere else, or they try to use your machine to DDoS somebody else. They can do whatever they want. So Cowrie is a medium interaction honeypot. It means it sort of gives you an emulated system which looks at first glance like it's a Linux system. It has all the common commands that you can run. A lot of them won't work. And actually, it's not a real system. It runs inside sort of an emulated Python system that just pretends to run these commands. But it's enough to usually stop a script. Actually, not stop a script, usually to fool a script. So we'll just run a script automatically. And it's enough to usually fool an attacker for a couple of minutes as well, unless they try really, really hard. What it also does, it captures full user interaction. So we actually do sort of a screen recording of whatever they're doing. If they try to download anything, if they try to download or upload any files, all of those are saved. And it can be analyzed later as well. So it's really useful to see as well, what are these attackers trying to do with the system? Are they trying to download malware on top of it and get a copy of that malware? And then maybe further you can analyze that, do some malware analysis or send it to popular websites to analyze that data. So that is Cowrie. If there's any questions at any time, yeah, we're not in a very, very large group and I've got plenty of time. So just raise your hand, yeah. If you've got any questions, let me know and I'll try to answer as best as I can. Now, let's do a quick demo just to see what we're looking at. So over here, and this one runs on my local server. I've got Cowrie running and I can connect to it using this command. This is SSH, secure shell, P for port 2222, because I'm not running it on a normal port, I'm running it on another port. We can talk about that later, why. And then the user ID I tried to log in with. So I can log in and ask me for a password. You can actually configure which password it will accept, but right now we will accept anything except the password root. So I can just type some garbage and basically I'm logged in on the system and it looks like a Linux prompt. I can do ls, I don't see anything, I'm in the root directory, so it's empty. I can go to /etc, I can do ls, I can see all those files there, I can do cat password, oh, that seems to work. I can even do advanced things like grep for user ID fill, that will works. I can copy password to password 2, well, that works as well. Now I have a new file, password 2, and that works. I can go wget, google.com. Hey, am I not on the internet? Well, I think my laptop's got an issue with connecting, but that was working last I tried. So I can actually download a sample from a website if you probably try to download some malware. And it's got basically the capabilities to look like a normal Linux system. Now the cool thing is when I log off and I log in again, and I look for that password 2 file I'll create it, it's not there. Yeah, so every time you connect to this system, the new user gets a freshly provisioned environment. So somebody can't go in and delete all the files and then make it impossible to log in for the next user. It just creates a new virtual environment and you start all over again from scratch. The nice thing is I can also go to SARS, Cowrie, varlib, Cowrie tty, and I can do play log one of these files. Now actually, you can sort of replay the prompt. Was this one I just, yeah, I was talking a lot, I think, so that's why there's a lot of this. So actually replace the entire interaction. So this is one of the first sessions that I did, tried to run a few commands. So you can see what I did. So you can actually go in and replay whatever the attacker was doing. And you can actually create a log file as well with all the commands that you're running. And you can then use that log file to analyze it in another system. I can send it to an Elastic system or a SIEM system or a Splunk to further analyze the output of that. I can take the samples, send them to VirusTotal, or I can upload them to an S3 bucket to analyze later. So I can do a lot of things. And basically, it'll just capture the entire interaction. I'll show you the log file as well. It's 2 log files by default. One is a log file. It basically gives you in detail what people are doing. So go to the end. You can see here, this is that command that I tried to type. Command ls-l pass password 2. And that was the log off that I did using the Control D. You can see it's writing that TTY log file. So that's the one I was maybe just replaying. And we can see a lot of protocol dependent things here as well. There's actually more that happens behind the scenes in the SSH protocol, and we log a lot of those details as well. If they try to log in with a public-private key, we will actually capture the signature of that key. If they set certain environment variables, we capture that. If they set certain screen size parameters, like they have a 80 by 24 term, we actually capture that. So you can use that later to compare that to different attackers groups and see if it's the same person the same malware trying to log into your system or not. So that's in a nutshell is Cowrie. So the basics, just SSH. We do this for Telnet as well. I'm not going to show Telnet, but it works pretty much the same as it does for the SSH version. The picture, by the way, is a Cowrie. Maybe good to explain as well. A Cowrie is a type of shell. A shell that you find usually in the sea, on the water. If you like to scuba dive, you can find them. The pink one here is one that is a Cowrie shell, and it's a bit of a pun in the way that it creates an emulated shell. Cowrie is a type of shell, and that's why it's got the name as it is. Cowrie is actually quite popular shells. They used to be one of the earliest forms of money. Somewhere in Africa, they used to use those shells as, instead of coins, they used to have these little shells that they used as coins to exchange with each other. So those are also Cowrie shells. They've been quite popular through the ages. Cowrie, and we're going a little bit more into the guts of things about how it works and how it's written. We'll go a bit more technical as well. But basically, it's written in Python. So it's a whole set of Python code. That's sort of that snake on the top left. That's how I program the honeypot, how you can go in and change things as well. Now, on Python, there is a framework called Twisted. Twisted is an asynchronous programming framework to provide network services on Python. So I can run a web server in Twisted. I can run an SSH or a Telnet server in Twisted. I can run an IMAP server or something else in Twisted as well. So it's basically the programming framework on top of Python that I'm using. Inside Twisted, there is a particular framework called conch. This one here, so that's a conch shell. This is also a pun, actually. So conch is the secure shell framework that's inside the Twisted framework. And on top of that, I've written Cowrie. So it's actually just built on a stack of software, yeah, starting at Python, then Twisted, then conch, and then finally on top is Cowrie that provides the whole file system emulation. What actually those other systems provide for the software is the ability to log in, to deal with the encryption, to deal with the private key login, part of the, actually not even, no, the logging and storing the logs is all part of the Cowrie software. But it basically gives me the foundation to deal with the SSH protocol. History of this, it goes actually quite a bit back. Yeah, I didn't write this from scratch. If you look at the history of SSH honeypots, the earliest one probably was around 2006. It was called Cojoni. I don't know how to pronounce it. Maybe based on the Spanish name, Cojoni. Around 2006. Then, around 2009, Kippo came up, written by Uppi Tamminen from Finland. And he actually wrote from scratch, not an adaptation. He wrote Kippo. And back in 2014, I had some spare time and I started to modify Kippo. So I started to create patches, I added functionality, and we'll talk about what sort of things are added later on. And I started adding actually quite a lot of stuff, and it kept growing and growing. A few of my patches were accepted by Uppi, but at some point I think I did too much or he was too busy. And a lot of the stuff that I built was not included in the original honeypot in Kippo. So actually I reached out to Uppi. And I said, I want to just make my own copy of this, fork it. It's open source software, so you can do that. He was all right with that. And at some point I renamed it as well to the Cowrie name. This is 2015. So it's about 10 years ago now that I set this all up. This is good best practice as well, I think. Yeah, you can just take any open software and go and fork it. But I think it's always good to get a blessing from people. Yeah, and you see that Uppi isn't actively working on Kippo anymore. It's sort of been neglected a little bit, but that's okay because he's got other priorities he's working on. So that's the history of Cowrie. In the last Yeah, 10 years. It's quite popular. I've got a few thousand stars on GitHub and about 1,000 forks or something. I know it's being used by quite a few parties on the internet to gather threat intelligence, but they don't always tell me what they're doing with it. Yeah, sometimes I get hints, or sometimes somebody will release a research report where they mention Cowrie by name, but quite often they don't. Yeah. The threat intel companies will just mention there is an attacker group doing this and this and this, but they don't actually say how they got that information. But sometimes reading between the lines, I can make out that they're using Cowrie to capture that. So I know Shadow Server's running quite a few honeypots. I hear in Taiwan they're doing quite a few other threat intel companies, and some of the big brands are also using my software. But again, they don't tell me anything. They just take the software and they run it, which is also fine with me. We'll talk about one example later on, yeah, about people who used my software. Now, the typical input will look something like this, yeah. So these are sort of the commands that they'll be sending to the honeypot. You don't actually get a lot of humans that try to log into your honeypot. 99% will be automated scripts that continuously scan the internet. It will run a standardized payload. It will try to log in. It will run a few commands. Sometimes it will just basically send all the commands straight away and then sort of log off. Sometimes there's some checks in there and will disconnect if things don't look quite right. So they have a bit of honeypot detection in there. So you see that as well. But most of it will be fully automated, and you'll be quite lucky if you get a real human in there. You can find the real humans by the fact that they type a lot slower. So you can look inside your TTY logs, you can look inside the time between the different keystrokes, and from there you can take an average and then easily see this is probably a human and this is a fully automated script. So there's all sorts of interesting analysis you can do once you have that data in a system where you can analyze it. There's all sorts of tricks that people do to try to circumvent honeypots or try circumvent detection rules, and you can see some of those things on the screen. Yeah. So at the top, cat bin ls to determine hardware architecture. They will actually cat is display a binary on the screen to find out which operating system you're running. Look at the first couple of bytes of that file and then try to determine this is an Intel system or an ARM system or something else to determine which file to upload next. We can see those methods there using cat type pipe SSH and then basically ways to transfer files. And these are some of the extensions I did that Kippo initially didn't support. People were very creative in how to upload the malware to the honeypot. Rather than just using a wget or a curl command to download something, they would try to upload it using SCP, which is secure copy, which is a way to transfer files over SCP, or SFTP, which is another way to move files over SFTP. Over SSH, or TFTP, or just web downloads. Yeah, there are many ways to get your files where they need to be, and you're continuously modifying and updating the honeypot to see what are they trying now to get the binaries on the system, and how do I support this and actually also capture that data in the process that they're doing that. This is quite typical as well. You get a whole pile of commands, so we'll try to basically download everything and run all those things and just see whatever works. Yeah, a lot of these automated scripts just try a lot and see what sticks. Throw against the wall and see what sticks. You see more here where they're running those echo commands with the sort of binaries in there. Sometimes they actually run echo, a lot of echo commands, and actually sort of create a binary in that way. Yeah. So again, I need to monitor that, need to see the file that is written to. Cowrie can actually do that, and then take the concluded final sample, and then you want to send that to further analysis, like a virus total or somewhere else. And then there's base64, encoding, decoding. Again, all these tricks to get past any detection mechanisms or honeypot detection mechanisms. So how to deal with those things? Typically, I run a few honeypots myself on the internet. I examine the logs once in a while. I see, are there any errors? Are they trying something new? What type of commands are they running? What are the popular commands? And also, what are the unpopular commands you're running? So you look at all the output and you sort that by how frequent they are. Because a lot of the automated scripts, they will do things like 100 times a day, 1,000 times a day. It gives you a large amount of data. The more interesting data is the one that are less frequent. That's happening. Then you usually compare with the real system, because again, it's emulation. It's never 100%. the same. You're going to see, does it give sort of the right output? And then if necessary, you update it to make it look more like a real system. We'll come back later to other ways to make it look more like a real system, because there's ways to do that as well. So some of the things that were added over time, things like telnet support didn't used to be there. So telnet's mostly phased out now, but in some OT, old IoT systems, or some router, home router things, you can still find telnet. So we've added that, and it was quite popular with Mirai, about which I'll talk later. Yeah, we've added SFTP, SCP, which are different ways to do file uploading. So with SFTP I can upload files through the SSH protocol, and in SCP I can do the same thing, but technically it's implemented in a different way, although the effect is pretty much the same. Things that were added was wget and curl, the ability that inside the honeypot, they will type wget or curl to download a binary from the internet. You want to capture the URL, and I want to send that to some place to be monitored, and I want to capture the binary that comes out of it to send it to some place to be monitored as well. And then the last thing that we see as well is called direct TCP forwarding. So SSH has the interesting capability of functioning as a standard TCP proxy. So that means I can route everything through an SSH connection. It will come out at my SSH destination, then go on the internet. What we see is people are doing this, and they will try to use your server, which is vulnerable, as sort of a jump host, either to connect to SSH to another server, or to send spam through an SMTP host, or to do something else by using your, let's say, hacked or compromised SSH server. So we wanted to monitor that as well. And the easy part was to monitor just what are they trying to do. But what actually written is a way to take that connection and redirect that somewhere else. So I can make it in such a way that if you try to connect to a port 25 SMTP through the SSH as a proxy, it will redirect you to another system rather than the system where you wanted to connect to. So you can send it to an SMTP honeypot and do further analysis. So that's another interesting thing. That's be the last exercise in our lab today as well. Yeah, so most of this was built on what I saw the attackers do, and then you build out emulations for these features. Yeah, it does mean you're diving into the SSH protocol quite a bit, but it's quite interesting because there's a lot of different features and capabilities inside that system. Now, who's heard of Mirai? Oh, okay, good. So Mirai was big, was big 2019 or something, 2018. This was a piece of malware that was self-propagating. It would go on the internet and it would try to scan other systems and then replicate itself. It's a bit like a worm, almost. And it was originally written as a bit of DDoS software. Once it would compromise all those systems, it would then be used to DDoS, I think it was back then, was it Discord servers or some other sort of online chat system they wanted to make, Minecraft, I think even, to DDoS Minecraft servers. It was written by some teenagers in the US. It's not even super advanced, but it sort of spread and they released the source code. And then everybody took that and copied that. And it's still probably one of the more popular strains of this type of malware on the internet that you'll find when you'll run a Cowrie honeypot. So super popular. The guys got caught eventually behind Mirai, and I have it on good faith that they actually used Cowrie to run about 1,000 honeypots worldwide to gather the evidence that was used in the court case to find and actually convict the authors of the Mirai software. So that's an interesting one where they actually sort of heard through via on a conference that they actually used my software to do that. The Mirai guys actually signed a contract with the FBI, I think, and now working for the other side. Now they're actually working to stop types of malware as well. I think probably in return for reduction in penalty. So that's Mirai. If you hear that name or if you see that software, it'll come through quite a bit, and after a while you sort of recognize the sort of patterns of what it does. So it's an interesting one to read up on. There's a whole story behind this. The other thing that was added over time was more shell commands. Yeah, so the original Kippo had the ls and the cat and the cp, etc. But I've been adding a lot of more commands, and and to make it more appear like a real system. So that grep command that I executed, the way that the pipeline works, the ability to do standard output, standard error, and redirect that one, all the things you can do on the Linux shell, a lot of those things work on Cowrie as well. And I had to do this because the attackers were using it in their scripts. Yeah, and they're using these tricks, particularly try to avoid the honeypot. So it's a bit of a cat and mouse game. They try something new, a more complicated way to write what they try to do, so it'll break on honeypots, and I have to go in and change something so that it sort of works again. Yeah, but it is a bit of it's a losing battle. Yeah, you can never really fix it 100%. I don't want to implement every Linux command in Python on my honeypot. It's just too much effort. Yeah. Oftentimes I get on GitHub, I get requests, can you implement this command? Can you implement this command? And then the question is like, do you actually see this? Do you see attackers trying to do this? And then the answer is sometimes no. And then there's really no point in trying to build that out. Yeah, because it's just a lot of effort to try to copy an entire system without any use. So we'll always be a little bit behind. I will always try to do as best a job as I can, but there will always be things that will not be supported, and there are things that will never be supported because they're just not used by the attackers. So we try to see what the attackers are doing, and we add functionality for that. So, for example, heading the redirect ones was something we added, the piping in malware through SSH, catting bin ls, and then providing the right binary was something that we added. Adding the binaries inside the echo command, base64 decoding. So these things are all in there, and they're all basically built on things that I see the attackers do. More commands, if config, lspci, they often run this. So a lot of what you get as well is things like crypto miners. And crypto miners are interested in how many processors do you have and how much could we use to do crypto mining. So they'll run commands like that, like the lspci, like ifconfig to see what's your outbound IP address, how many processors do you have. And there are various ways to request that, either from the proc file system or by running something like lspci. We added commands like du curl, apt, cat. Some of them, they do what they're supposed to do. Some of them give a realistic error message but don't work, and some of them plain just don't work. What we also added was the output plugin framework. So there was a lot of demand always to take the data and do something with it. And initially there was a database output plugin to put it into a MySQL database. We've been expanding to this, and by creating an output plugin framework, everybody can write their own plugins to tap into specific events that happen inside the honeypot and then do something that you need. So right now there is maybe 20, 25 different output plugins that can send output from what's happening to Discord or to Slack. Yeah, just log output straight into a chat system. It can send samples to VirusTotal. It can send it to SANS, data to SANS. It can send it to a database of your choice, from Redis to Influx to PostgreSQL. We recently added just a couple of weeks ago, MySQL, Oracle Cloud. You can upload binaries to Amazon S3. You can send samples to Cuckoo, Sandbox. Anything else interesting? I think MISP as a threat intel management system. Yeah, so you can upload your events to MISP and then automatically consume them and add the source IP address to a list of indicators of compromise. So it's really good as well if you create a plugin system, because most of these are not written by myself. Most of them are written by other people. So try to make your software, if you make it extensible, it's really good to get more people to use your things. A lot of work has gone into programming, programming Python to be precise. Yeah, if you haven't programmed Python, there was a big migration from Python 2 to Python 3, which basically meant that I had to go through the guts of all the software and convert things at a very low level from 2 to 3. There are some really significant changes in how strings and arrays of bytes were handled. Python 2 and 3 do it in fundamentally different ways, which means I had to go through all of this and get this fixed. Yeah, that was probably quite a significant effort, but now we are conforming to modern Python, and I try very hard to keep it working on the latest versions as well. Most of my effort these days is spent on more maintenance work. It does sort of what it's supposed to do, But now the ecosystem around Cowrie changes all the time. New versions of Python, new versions of Twisted, new output plugins, changes in dependencies, etc., etc. You want to keep on track. I'll talk more about this later as well in the CI/CD part. But I need to keep track of all of this, and it takes a certain amount of time, yeah? So you want to stay on top of what happens. If you neglect this, then your technical debt gets too much, and it gets very painful to clean up. You don't want to be too fast either, because then you'll be the first one to experience all the problems. You want to do sort of a happy middle ground where people have solved the worst things about the new things, and you solve the bugs in the new software, and then you can adopt that and move quite quickly. Yeah, so ultimately, having the shell emulation and a limited number of commands is always going to be a limited way to provide a honeypot. What we really want to do is a high interaction honeypot, where I emulate a full system. So I don't have to write those commands, but I can still monitor what's happening. Yeah. So in 2019, I applied through something called the HoneyNet organization, which is a worldwide group of people who do things with honeypots, and I applied for Google Summer of Code sponsorship. This is where Google pays an open source developer for about 3 months of work to improve your piece of open source software. So I actually could pick an interview, in this case a Portuguese student, Guilherme Borges, who we gave an interesting task to do, is to take Cowrie and turn it from a shell emulation into a proxy. And not just a proxy, an SSH proxy that would monitor the traffic, but also run a number of emulated systems on the back end using QEMU. If you're familiar with that, it's a system to emulate different types of processors. So we can even load different types of firmware from like cable modems or something else, and then, or an emulated system, run that in an emulator and then connect it through Cowrie, and then use Cowrie to monitor that. Yeah. So this is, if you've got an open source project, it's a fantastic way to get additional hands to work on your project. This worked really out quite well. He created that system. He added all the features. It's a shame he left, because now I have to maintain it. But I think it was a pretty much all-round success. The problem is just transferring indeed that code, back to the original maintainer, because some of those parts are a bit like mysterious for me how it works. But it was a good addition, and I really enjoyed the project to work. And you also get a lot of attention this way, because it just brings your project more visible, in the GSOC and other places. The other thing I have to deal with a lot is fingerprinting efforts. This is an interesting topic as well. There are always people who write these blog articles like, oh, I found a new way to detect the Cowrie honeypot. Because if I run this and this command, then it breaks. And now I found out it's a honeypot and not a real system. And then they write a really popular article about this and say, like, I've broken the honeypot emulation. Okay. But again, this is one of those sort of cat and mouse games that's going to keep going on forever. It's more interesting because there are these internet scanning companies that scan the whole internet, and then they want to know which is a real SSH server and which is a honeypot system, so that when you take that intelligence, you can use that and see, for example, already this is a real system or not. But I think we're doing quite well. We found a few bugs in how it was implemented, and there's enough configuration options that currently my versions I'm running myself with slight tweaks from the default configurations are not being detected. So there is a bit of value as well in taking the standard honeypot and then modifying it so it doesn't actually look like the default one, because the default one's quite easy to detect. People detect the username, for example. The username used to be, I forgot it. It used to be a certain username in there, and then I changed it to Phil as a sort of a joke. But now Phil is being used as a way to detect the Cowrie honeypot as well. So if you deploy one of these, you want to go and change it so it's quite different from the default standards. And just as well, you can change more low-level SSH version identification. File system can be fully changed. Login prompts can be changed. We'll do a bit of modification in the workshop as well. Generally, modification happens two ways. So identification happens two ways, either through commands that you run that fail, that one's quite difficult for me to stop because, again, we're not implementing all the commands. So if they find out that you're running a particular command, it doesn't work, okay, I can't do too much about that except implement that command. But there are a few clever people who found out how to get it from lower level SSH information before you even log in. So slight differences in the way the Twisted library handles the SSH protocol versus how OpenSSH doing it. And even to the point of looking at TCP sequence numbers and quite low level things in the IP stack to find out whether it's a real system or not. And those approaches are really hard to do. Yeah, University of Cambridge did one like this. You had to get a really low level detection in there. Yeah, the only way you could do that is by taking the OpenSSH binary, I guess, and using that to proxy it towards the Cowrie system to really avoid those low level errors. Again, it's an eternal cat and mouse game. As soon as I find out people use a certain way to detect it, I try and plug that hole. But like a lot of security, it is this cat and mouse case where the attacker is doing something and then the defender needs to do another thing, and you just basically keep each other busy. As well, if you run a project like this, it's good to have an internet presence. Yeah, so I've got a GitHub organization where you can go and download things. I've got a Docker containers you can download using the Cowrie organization, so it's easy to find, easy to download. I've got a website, I've got Slack server. So if you're interested, go to any of these to learn more about the project. Yeah. So again, if you want to do something like this, make it easy for people to find you. In the last few years as well, I've focused a lot on CI/CD and DevOps practices, yeah, to make life from a developer perspective easier. Maybe as a security person, you don't think so much about this, but actually having this piece of software, you're having to test it on different versions of libraries, different operating systems, different processors, is something that actually takes a bit of effort. So, and this is the nice thing about a project like this, it'll teach you about other parts of IT as well. It taught me a lot about, for example, the DevOps practices and about programming as well, rather than just the security aspects. So I started with writing unit tests because the shell interaction, where it parses your shell line and uses those pipe symbols and stuff, is actually quite complicated. It's quite easy if you make a small mistake in one command, so a small change in one command, it will break some of the other things. So I wrote a test suite for a lot of the common shell commands, and every time I make a change, I make sure the test suite passes to make sure that all the things that are built in there so far are still functioning. And then we automated that using PyTest, unit test, so I manually could run that. And then I added Tox to run a whole testing script on different types of versions. And then I added that to Travis, which is one of the early CI/CD systems. So it would run it for me rather than I having to run it all the time. And now it's running GitHub Actions, which means whenever a piece of code is changed in GitHub, you open a pull request. The pull request runs an entire test suite to make sure that it passes all the requirements. Your formatting is correct, all the commands still work, and it meets other requirements I have as well. And it will tell you the results. And then I can decide to accept or decline the pull request. And even my own work is going through the pull request mechanism to make sure that I stick to the same development standards as well. Yeah, and this has been really useful in my day job as well, because my last job was working at HashiCorp, which is a big DevOps company working a lot with Terraform and other systems, and it really made me understand the whole developer lifecycle as well. Yeah, and this is the other thing as well. This project is something that's on my resume. I usually talk about it when I've got job applications, and people are usually quite interested. Yeah, because it's sort of semi-popular. It's something that you do on the side. It shows that you have the technical skill and the capability of doing a thing like this, and it usually looks good when you go in things like job interviews. Yeah. So again, this keeps updating as well because the Python ecosystem keeps moving as well. So we added code formatters, linting, and now using Dependabot on GitHub for software updates. So whenever the underlying dependencies change, and this is the problem these days with a lot of software, is the supply chain attacks. Yeah, you're using Conch, which uses Twisted, which uses OpenSSL as a library, for example. There's a bug or something in OpenSSL, which basically could be potentially exposed all the way downstream in my piece of software. Yeah, so I'm using, for example, Dependabot to keep track of all the Python dependencies and other dependencies. Whenever something needs to be updated because there's a security bug found, then the whole pipeline will go automatically create a pull request, test that the software works on this particular version, and the only thing I have to do is just press a button to accept that, and it just updated automatically, and it automatically after that build new containers and new versions of the software. So it's a fully automated development pipeline. So not really a security thing, but really interesting to look at from a computer perspective as well. Docker. Yeah, Docker's taken, not so much Docker, but containerization. Containerization has taken the whole sort of software deployment world by storm. So we've added this as well to make it really easy to deploy. Yeah, in the workshop, we'll deploy it the old-fashioned way because it's a bit easier to configure. But a lot of people use the Docker way of doing this as well. So we've added Docker containers. That was a learning process as well. Now we're using even more secure distro-less images that don't have certain binaries. So even if the honeypot could get compromised, and I haven't heard of anybody who managed to break out into a real shell since I've been running this for the last 10 years. But if they manage, then they're still on a very limited Docker container where they can't really easily break out again to the real operating system. And we're separating build and run stages. We added configuration through environment variables to run it easy in like Kubernetes and other places as well. We've added new operating systems, new processor architecture, like using ARM as well. It can run on a modern M1 to M4 macOS book, for example, using the Docker container. It really makes it easy to deploy in a default configuration, but the container setup is actually quite difficult if you want to go change the file system. So it generates also a lot of questions to me while people try to do things using Docker. Yeah? So it's actually easier to deploy and easier to modify using a standard shell mechanism rather than using a Docker container, because you really need to understand how Docker works and how it deals with file systems, particularly persistent file systems. The future. Yeah, it's mostly in maintenance mode now. I mentioned already, yeah, I add update dependencies, I fix bugs, and when people put in pull requests, I will accept those if they're good. And we're adding still like new output plugins to it and new commands to it. So there's still progress. There's one project I'm working on in my spare time, which is not public yet, is to turn it into an LLM for the output. Rather than having an emulated file system using the Python commands, send it to ChatGPT or a system of your choice, and it will generate the output for you. It sounds good in the beginning, but there's a cost, of course, to consuming a lot of tokens on an LLM. And if you run on the internet, it'll probably go through quite a few tokens quite quickly. But it is interesting enough to write it. And I'm actually also using the LLM to help me write the code. So this is work in progress, but it looks quite promising so far. There's a few other people who wrote this already on the internet. I've seen a few people who started doing this. Well, I added into Cowrie as well. The nice thing, I get to use the whole existing infrastructure I have already, including the logging, the terminal monitoring, the output plugins and stuff. Yeah, all of that stuff I can leverage and just use a different backend. So right now there'll be there's two backends right now. There's the proxy backend, there is the emulated shell backend, and there'll be a third backend, which is the LLM backend. Then there's more work ongoing for the proxy mode. There's mostly dependency work again, where Linux is changing from IP tables to NF tables, which sort of changes how I deal with the network on the back end of having multiple honeypots behind the proxy. But that's just more technical work that I'm waiting on other people to fix things in their libraries. And that's where we are with Cowrie these days. So it's been 10 years, I think. It's been quite good, yeah. It's giving me a lot of exposure to different aspects of security. It's helped me in things like my career and job interviews. I literally had job interviews where people said, oh yeah, I used to run your software. Oh, you're the guy. Yeah. So that is actually good. I've met lots of interesting people. I got to work with the Google Summer of Code. I worked with HoneyNet. I got a speaking engagement in Australia at some point at HoneyNet conference, where they basically flew me to Australia with expenses to present at the HoneyNet conference. So it's giving me, I've met people in Singapore as well. I've been here 5 years now. I've met some people as well through the work on Cowrie I've done, through the local chapter of the HoneyNet system. So it's been really, really fun actually to do this and to do this. The question I get as well often is about commercialization. So why don't you turn this into a company? Yeah, and of course I've thought of that. But you see that the audience for this is primarily two parties. One is novices in the sort of cybersecurity space that want to see what the honeypot does and play around a little bit. And then it's the threat intelligence companies that want to gather intel, and they run my honeypot at scale, but they don't tell me what they're doing, and they probably don't want to pay for it either, because they would just take an old open source copy and copy that and use that. So I think the opportunity for turning this into a company is probably a bit limited, but it's still interesting enough to keep going for me to learn as well. Yeah. So next is a workshop. But before that, any questions? Anything you'd like to know? Anything you're curious about? Yes.
Just curious, why you starting the project Cowrie? What the background of?
Oh, I was in between jobs. Yeah, I mean, that's the answer. I was in between jobs. I had about a three-month window or something, and I just didn't have that much to do. I wanted to keep busy, and that's why I started playing around with Kip originally, and then I started modifying it, and it sort of grew from there. It sort of grew organically. Yeah. Good, welcome. Anybody else? Yeah.
Some hurdles where you're developing Cowrie.
So, yeah, plenty. So the twisted programming framework is actually quite difficult. Yeah, it really, because it's asynchronous programming. It's really sort of upside down programming. It's not like normally you write a program that says do this and do this and do this. It's more like wait for this and wait for this and wait for this and wait for this and then do something. And if then this happens, then do something else. So it's a really weird thing you get to work around. I wouldn't be sure if I would like reuse the framework if I had to do it all over from scratch. The hurdles, I think that's from a technical side. Apart from that, not too many hurdles. Yeah, you just have to invest the time to learn how to do things. Yeah. Yeah. Thank you. Anybody else? Yes.
Do you feel like the motivation to like continue the project for so long? I mean, it's going on for like 10 years already.
It just flew by, to be honest. Yeah, I haven't. Sometimes I don't do I don't do anything for months. I'll just approve like my automatic PRs that are running from the CI/CD system. But sometimes I just get inspiration and I say, oh, I want to do this, and then I go out and build something. So, and I also use it as a way to learn other things. Yeah. I needed to learn Terraform in my previous company, and then and just learning Terraform in itself is a bit boring. So okay, I'll write a Terraform to deploy Cowrie. Yeah. So, or I need to learn CI/CD. Okay, I'll do CI/CD with Cowrie. Or I need to parse logs from a system. Oh, I'll use Cowrie logs. Yeah. So whenever I need a toy system to do something, to learn something else, or I want to learn cloud stuff. Okay, let's try to deploy Cowrie in the cloud. So whenever it's my toy system to learn anything else, I just try to connect it, whatever I'm trying to learn at the time. And that's really good as well, because it gives you something practical to do, and a goal to learn something new.